So in this problem, we have a piston and cylinder device. It's losing heat and electrical work is done on the system by this heating coil. Let's assume that the system is expanding, so the volume increases. That means boundary work is done by the system on the environment because piston is pushed out. Now looking at the equation, we can see that there is a negative sign in front of W. That means this is a formal sign convention. Therefore, Q in should be substituted to the equation with a positive sign. W in should be substituted to the equation with a negative sign. Since this is a closed system, we know mass flow rates are equal to 0. So both of these parts with mass flow becomes 0. Also, we are assuming this is a stationary system. System itself is not moving. So we are assuming kinetic energy change and potential energy change of the system is equal to 0. Since energy coming into the system or going out of the system and kinetic energy and potential energy of the system is equal to 0, we have this equation as our energy balance equation. So this is a generic energy balance equation for any closed system. Now let's consider our system. In our system, it is told that Q, an amount of 2800 joules, is lost from the system. So we can write minus Q, because we are losing heat, minus W is equal to delta U. Now that is heat transfer through the system boundary. What about work transfer? When it comes to work transfer, we said that we are assuming boundary work is done by the system on the environment. So boundary work is going out. It should be positive. So we substitute a positive WP. And that's not all the W's that we have in this system. We have electrical work. Electrical work is coming into the system. And according to our formal sign convention, work coming into the system is negative. So we put WP with a negative sign into our energy balance equation. On the right hand side of the energy balance equation, so this is our final form of energy balance equation.